So it's actually quite amazing how much hair we have in the office, isn't it, Shawn?
Where do you get the hair from?
Yeah.
I will be super honest. None of the stuff that I've worked on has come out as a product yet. It doesn't mean that the work wasn't done.
It must be heartbreaking to see like these dupe versions of Dyson products.
I
Right?
mean, I suppose imitation is the ultimate form of flattery. It actually sucked my hair in, and I was like, oh my goodness, like, this is a nightmare.
Hi everyone, my name is Daryl.
And my name is Lynette, and welcome back to another episode of Thriving As.
Engineers, or more specifically, Dyson engineers. So today we break down and demystify what an engineer does and hopefully share some advice for aspiring engineers.
So can you introduce yourself and tell us what you do at Dyson? Perhaps we can start with Shawn.
Sure. Hi, my name is Shawn. My position is Head of Research at Dyson, based in Singapore. So in my role, I actually lead a team of multidisciplinary scientists and engineers. We focus on really some fundamental technologies that drive next generation of Dyson products.
Hi, my name is James Dsouza, and I am the head of one of the engineering departments in Dyson, Singapore. And similar to Shawn, like I do look after a team of engineering specialists. So we have engineers with very diverse backgrounds and specialties. They're based in Singapore in our 3 campuses, and yeah.
So, I mean, the first thing I think about when I think of engineers, right, are like people wearing the hard hats and the high-vis jackets. But from your introductions, it doesn't seem like that's the kind of engineering you do. Is that right?
Well, maybe I can speak for myself first. Not in my team, no. That's not really what we do. Actually, most of our work is bench-based or lab-based. We test on very small setups. We try to model real-world situations from the lab. So we actually are in the business of making consumer devices and beauty devices, right? So they're not really giant equipment anyway. So a lot of tests that we do are quite small and contained.
So you're not required to wear any gears and whatnot?
Well, we work in the lab, so of course we have to have some safety, lab coats, goggles, things like that for basic safety. But it's not really outdoors or under the sun.
No hard hats.
No hard hats, unless for fashion.
Yeah. Maybe at the year-end party.
Yes. Yeah.
Costume. But yeah, I think a lot of engineering these days is actually on simulations. Computer simulations is a lot. Computer modeling simulations is a lot of what we do. Yeah, so I do agree with Shawn. Like, yeah, that is a stereotype, but it's not really not really true.
And there are also a lot of different fields of engineering, right? Like for yourself, you are in, I assume, biochemical engineering, is that right?
So I was trained as a chemical engineer, and then I moved into bioengineering. So actually, most of my background was looking at how to combine understanding of the human body with engineering principles. So how to make things with that are devices, basically, that can work on people. So we've translated a lot of that knowledge and understanding into what we're doing now. So if you imagine a beauty device, a Dyson beauty device, a hairdryer, a hair straightener, it interacts with your hair, it interacts with your scalp. So how do you do effective, safe styling but still maintain the health of your hair and your scalp? So very, very simple things that translate quite easily into the day-to-day of what we're doing now.
So it sounds like you are kind of a scientist. Would you describe yourself as a scientist?
Well, I hope we are not kind of. We definitely do follow very much rigorous scientific principles, right? So we do tests, we retest, we test against controls, we test against competitors.
I see.
We make sure that the way that we set up the test and the experiment, we call it experiments, is exactly the same thing, are as reflective of real-world situations as possible, as much as we can get them. Sometimes we have to close the gap, like James says, with simulations, with software. Very much a marriage of the two right now. And in fact, most of the work is a combination of software, hardware, and in-lab testing.
From my understanding, it was like the scientists are the ones who do the experiments, they come up with the theories, and then the engineers take those theories and then they build products based on that. But it seems like it's not that clearly defined, right?
Yeah.
There is a lot of overlap. I think engineering, by definition, is the application of science. So we work so closely with teams like Shawn's, and especially if you're making hair dryers. And I think Shawn alluded to this as well. One of the hardest things of working with hair care products and designing hair care products and innovating around hair care products is there is really nothing out there like the human hair. So if you are actually designing a hairdryer, a first of its kind hairdryer, you're gonna have to need a lot of hair. And no two hair types are exactly the same, and there's a lot of different hair types. So it's actually quite amazing how much hair we have in the office, isn't it, Shawn?
Where do you get the hair from?
Yeah.
There are, you can actually buy test to hair tresses, like that is a thing. So it can
Okay.
it can be bought, and you can actually specify the background, the type, the length. So this is a thing, and it's very routine now. We've been doing it in the Singapore office for more than a decade now. So yeah, so I think that's where the overlap is really quite strong. So I do have teams that look after the product performance of our hair care products, and you do have to work closely with people who understand the science behind hair health and hair styling. And at the same time, we need people who understand the product. And it's that marriage that's very difficult, but also very beautiful when it happens. Don't you feel, Shawn? I think that's
Yeah.
pretty much what happens in the actual labs these days.
Yeah, it's very informal. There's no line drawn.
Yeah.
This is mine, this is yours. That's not really how we operate. In Dyson, we're always making things that we try to make things that other people have not made before. So it's very much a spirit of adventure, right? So sometimes it's you have to try things that other people have not tried before as well, because there's no template for you to follow. There's no path that someone has done, and they're like, there's no right way to make this component fit with that component. You're just kind of reinventing as we're going along.
Like what some people say, the best ideas come from like the alleyways and at the cafeterias, not while you're seated at your desk or in the lab, right? So maybe James, you can talk about what you do on a day-to-day basis and your career journey, how you got to where you are, as well as some products that you've worked on, because I think there's one particular product that is pretty much iconic and everybody will have heard
Yeah.
of it.
Yeah, sure. My background is in mechanical engineering, so that's what I studied in uni. And I kind of specialized in airflow and temperature management, so aerodynamics and thermal engineering. So I did work on the supersonic, the pioneering team in Singapore, and I actually did also work on air wrap after that. So those are the two more popular products I worked on.
So be honest, how hard is it for you every time you see like a Dyson hairdryer to point out like, I designed that, I built that?
How do you feel seeing your products in store?
I mean, I think the interesting ones are usually the Grab drivers, to be honest, because every now and then I get they pick me up at St. James's Power Station, and they kind of conclude you're working at Dyson. So the question is, hey, do you work at Dyson? I was like, yeah. It's like, and then it's amazing the number of times, especially around Christmas, you get I bought the air wrap for my daughter. It's like I've gotten that 3 times last year, I think, at least 3 times last year. So even if I don't bring it up, it does come up, and then I'm just curious, right? So I just ask so what do you think about it? What does your daughter say about it? Like, what does your wife say about it? Like, do you like it? And
So your Grab ride turns into market research.
it does become a little bit of shop talk, but yeah. But yeah, and I think it's quite satisfying to see that people actually love it. I mean, usually, almost all the times the feedback is like, wow, we love it so much. I can't do without my hairdryer. So, for example, when you switch on the hairdryer, you kind of take for granted that it's running at a certain temperature and flow. But the thing is, someone out there has actually consciously put in a lot of effort to decide, okay, is this temperature the right temperature? And that was basically one of the things I did. So every supersonic out there, the temperature setting was specified by me, which is pretty damn cool when you think about it. And I think that's the thing that in these conversations, people don't appreciate, like when you say you worked on supersonic, they look at the outside, the product design, but then you're like, have you thought about there's 3 temperature settings, which means someone decided there's 3. Why are there 3? Why are they different? So those kind of things. So yeah.
So why are there 3?
Well, it turns out people do like choices. So yeah. But yeah, I think, obviously the strongest temperature is great for performance, but equally, if you, for different types of styling, you would benefit from more settings. There are countries where they prefer a lower temperature setting, so that is a thing.
I think on that note, I guess what is like a surprising engineering challenge that you think people should know, or something that people doesn't know about Dyson products?
This is a gross generalization, but typically when you look at engineering problems, there's 2 big categories of engineering problems. The first one, all of us will definitely recognize. So usually the first category of problems is something like this. So you need to make one of something, and you need to get it right the first time, no questions asked. And you will definitely recognize these kind of challenges. If you look at many of the architectural challenges, if you look at Marina Bay Sands, that's an engineering challenge. So there's only ever going to be one Marina Bay Sands, and you got to get it right the first time. So that's one category of problems. The second category of problems is the polar opposite of that, and that's the space Dyson operates in. And that brief is something like, you got to make 1 million of these, and they need to be pretty damn good. So that's a very different kind of problem. And I think people tend to underappreciate the challenges that brings in manufacturing. Everyone thinks, okay, yes, the product design is challenging, but actually making it manufacturable on a scale that you can hit start on a production line and 1 million motors, for example, come out flawless. That's the challenge. I think people don't appreciate the amount of detailed engineering that goes into figuring out absolutely tiny dimensions is really humbling.
And you mentioned earlier, something I didn't know about was that until recently, right, all of Dyson's motors were manufactured in Singapore.
Yeah, absolutely. I mean, honestly, it's something we don't talk about enough, I think.
We're talking about it now.
Yeah, because I mean, for the longest time, so Dyson's presence in Singapore started with Singapore's kind of advanced manufacturing landscape, right? So there is an ecosystem here of talent and suppliers for that allow you to really hone in on advanced manufacturing. So we got here in 2004 to set up what were our motors lines. So the heart of our Dyson machines are the motors. And the motors, like I said, are really challenging to manufacture. You need extremely complicated machines operating in a very clean environment to tight specifications. And even then, it's quite difficult. I think even back then, we recognized Singapore as the right place. And the motors have been manufactured for the longest time. If you bought a Dyson machine, some of our most iconic Dyson machines, whether it's vacuum cleaners, V8, V6, if you bought a hairdryer, if you bought supersonic, you bought air wrap, it doesn't matter what you bought, it doesn't matter where you bought it. For the longest time, if you bought that machine, that motor, the heart of the machine, was manufactured in Singapore.
And that's around the world.
All over the world.
All the
Doesn't matter
products
where
around
you
the world.
bought it. So it's like that's something to be extremely proud of, because that is the most complicated part of the Dyson machine. And it's manufactured right here in Singapore.
Maybe moving on to Shawn, can you talk about how you got to your role currently? Because you didn't start at Dyson for your first job, right?
No, I'm not a Dyson baby, unlike James.
Dyson baby.
But I mean, we've got many people in the company who are like you, right? Like started out as graduates and grew their entire career. I work with many of them. But I was part of a later wave of capability development, expansion. So my background, like I said, was in bioengineering, and I worked in the life sciences space for a while. And then there was an opportunity, and Dyson came calling. They said, hey, we want to set up this exact kind of capability in Singapore. Do you want to join us? And I was like, okay, well, let's have a chat. I don't know anything about a vacuum cleaner, which is basically all I knew that Dyson made at the time. I've seen the supersonic. It's like, well, I don't know if this matches my skill sets, but let's have a conversation. And it turned out to be pretty great. It was a space that, they said, we really need to build up some of this understanding. We want to do this in Singapore. We want to grow the local ecosystem, really invest in developing teams here. And that seemed like a great chance to take it up. So I did. And then I joined, do as you do, you submit your resignation, you get ready to take on a new job, join the company. And in 5 days, we had, this very interesting virus that went around the world, and then the whole of Singapore shut down, and globally everything shut down.
Right.
And they said, stay at home, don't come to the office. And that was kind of a fun, interesting time when they said, we don't know what the health situation is going to be. We don't know what's going to happen to the world. But hey, we want you to do all this ambitious stuff, build a team, build a lab, build up all these capabilities.
But do it remotely.
From your study room. It kind of brought people together in a way that we never did before. Because now you're forced to think differently. You're forced to work in a different mindset. 5.5 years on, we've got a good team. Everyone knows what they're bringing to the table. But because we work in the upstream space, we're actually always exploring new categories, new technologies, things that you don't even think will be into a product until 5 years' time, 7 years' time. But you're like, oh, well, maybe this could work. Let's try it out and see. So it's very much still a spirit of exploration that we've maintained over the years.
What do you mean by upstream?
So what James described, right? Getting stuff into a design that's manufacturable and then manufacturing it. That's what we typically call the downstream part of product development. The upstream part is the stuff that, you imagine, like, how should a heater work? That's like a very fundamental
So it's
question.
like a more theory approach.
Well,
Concept
it's
generation.
Yeah,
Yeah.
concept generation is a good word. So can we make something of this material? What if we made it of that material? What if we made it of a different material? Would it perform the same way? And then you make all these prototypes and you test it and you say, we ran it in this condition, we ran it in that condition. So the trick is that most people don't know what they don't like. Right? They're not good at vocalizing and saying, I don't like this specific thing. So that's actually quite a fun challenge that we try to do. Sometimes we observe them, we try to have interviews, we talk to users, and throughout the course of the conversation, it will arise and say, oh, I really hate it when my hairbrush does this. And then we're like, oh, well, okay, that's a good problem. What happens? And then they'll tell you, and then that can actually turn out into something interesting.
So as the head of research, do you get down in the weeds and go into the lab and do the actual experiments, or are you more like in a managerial role, managing different teams of other engineers who are doing their own separate experiments or interviews or market research?
Yeah, personally, I don't work in the lab anymore. I used to, but not
miss
anymore. Yeah, it's a double-edged sword, right? It's good to have the straightforwardness and simplicity of actually doing the work yourself. But in my role now, what I really get to do is I oversee different teams, and the teams that are actually doing the work. But also the interesting and fun thing for me is pulling everything together. We're still quite a small company compared to other larger competitors, and it's great because then we get to talk to all these people, and then they tell us, hey, I wish somebody would do something like this, or our customer feedback is this. Do you want to take a crack at it? So it's quite a interesting, very fulfilling role that I actually did not really get to do in my previous job, so I'm enjoying it very much.
I think from what you've shared, from what the both of you shared actually, there's a lot of like thought and like a lot of science and research behind each product. So can I ask like how long does it take for you guys to, to plan and to develop a product? Like how long does this process usually take?
Wow. There's no set period. Yeah. So we've had products that we get out in nobody's time, right? Like we're talking months, right? So we've had cases of months, but we also had cases of years, right? And that's that whole journey Shawn was talking about. Like you go from basically a concept and an idea, and it might be a great idea, but will it be a great product? And what does that product look like? What does it do? Will it actually deliver um,
It was intended to
what it
do.
was intended to do, right? So that whole journey, sometimes you kind of go from idea to product pretty damn quickly, but then in other spaces, there are so many iterations. So you try and you fail, you try and you fail, and you do it again and again, and you learn so much in that journey. And sometimes the product is nothing like what you started with, but you end up with a better product that does the job better. So
Are there examples that come to mind?
a lot of our well, just look at supersonic. Like when the first time we iterated it back in the day, it was a different concept altogether. But when we started, it was basically, can we put the motor in the handle? Like that was the idea.
Okay.
You have the motor to show us now.
I do actually have a motor to show you. I mean, it's funny. I mean, I don't want to give this impression that I carry a motor around in case a hairdryer suddenly stops working and I can swap the motor. But I do have a motor with me. So this is the motor that goes into our hair care products. So supersonic, air wrap, air straight, all of them have this. So it's called the V9 motor. Manufactured in Singapore, so you can see, you can have a look. It's basically the diameter of the old Singapore coin. So really small.
Does it say it's made in Singapore?
I don't think it actually says made in Singapore over there, but yeah, you can rest
Yeah,
assured it was made down the road in Pioneer.
So this little thing over here is the one that's driving your products.
Yes.
Oh wow! Like this is what you're paying for. Then like the consumers are paying for this.
So yeah, I mean, you can see what that unlocks, right? So if I don't have the conventional motor with me, but we're talking about about 5-10 times bigger than this size, right? And it was quite humbling because they were telling us like the biggest leap in hair dryers before the supersonic was actually in the 60s when people went from metal to plastic.
Oh.
That was the biggest
Right.
change they had seen in hair dryers. So it was quite humbling to hear that, like as someone working on the product back then. Yeah, and it was all enabled by this one technology.
So for the both of you, I guess as engineers, it's quite fulfilling to see products you've worked on become actual tangible things that you can touch and people are using out in the open, right? But what are your thoughts on counterfeit products?
Yeah, I mean it must be heartbreaking to see like these dupe versions of Dyson products, right?
I mean, I suppose imitation is the ultimate form of flattery. So
That's a nice way to put it.
yeah,
Yeah.
but it is heartbreaking. But I think what we are extremely proud of is the amount of conscious intent and design that goes, like that whole story, like that whole narrative of explaining, how you go from looking at what is out there today. Why is it so problematic? I don't know if you've used the old hair dryers or you've transitioned fully to the supersonics, but it's basically every time I go to a hotel now, I can't use the hairdryer. It's become problematic.
I know it's like
Yeah.
the white cream ones,
Why is
right?
this
With
temperature?
the coil.
It's like why is it so noisy? And
Are
then
you the kind that brings their own hair dryer every time
and
you travel
like, have
out?
you been in situations like I've actually I used to have shorter hair, and I've grown my hair longer, and now I understand some of the other challenges where, for example, we used to talk about how much better it is having the inlet at the bottom because it doesn't suck your hair in. And that happened to me in a hotel. It actually sucked my hair in. And I was like, oh my goodness, like this is a nightmare. So I've just started carrying my hairdryer with me right now. So
So do you use your hair as for research purposes as well?
I don't use my hair specifically, but yeah. So I mean, yeah. So I mean, yeah. It is unfortunate to see all the imitations out there, and I think it's even more distressing to think about how much less thought has gone into those because we understand. A hairdryer is a pretty complicated machine, okay? And there's a lot of things. It's a high power machine. We're talking about 1600 watts in that small package. You really need to manage that power well. So yeah, it's really unfortunate, but I mean, to us, we've as a company had so many design icons over more than 3 decades now. Whether it's the cordless vacuum cleaner, the original cyclonic vacuum cleaner, supersonic, air wrap. So I mean, we just focus on what's better out there. So many problems to look at, honestly. Any thoughts, Shawn?
Yeah, I think it's a big, it motivates me in a way, right? That you're like, okay, well, it was good enough to copy, so now we should think about what's next. We should think about the next generation of stuff that will be even better, and then it will make other people think, oh, we should have thought of that, and then they didn't, but we did, and we thought of it, and we executed it, and then we made it.
But I think beyond like the quality and the design, I think safety is also a very important factor to look at as well.
I think what we look for is longevity of the product, how long you can continue to use it, how long it's going to work at that level of quality without losing power, without losing suction, without getting clogged up, maintenance. I think that's the real focus areas I think that consumers should pay attention to as well.
There's this whole idea of planned obsolescence, right? That I'm not sure if it's a conspiracy theory or it's something that actually happens, where some manufacturers, they plan for the product to be obsolete in a few years. So I mean, is longevity really something that manufacturers really?
I think our philosophy is pretty much the polar opposite, which is we really want to make a great product out there. I mean, my supersonic is 9 years old. Like the one I use, I don't use it every day, of course, but it's really not even in consideration. Like I think what we are extremely proud of is how robust our machines are. I mean, you've seen the commercials, and those are actual tests in the lab. So we actually are quite proud about how much conscious thought and effort goes into designing a machine, a product. That is impressive. That does actually do its job well, but is also really robust because at the end of the day, this is going to be in actual homes, it's going to be in actual salons, and it's going to be under the real world, under all these stresses. And how frustrating it is, like if you wake up one morning, shower, and your hairdryer doesn't switch on, like. So it's not even an option. So I think we take kind of robustness of our machines really seriously, and I think that's what people recognize about a Dyson machine, right? People who've had a Dyson machine, like actually, it will last. It is built to last in those environments. So yeah.
So earlier you talked about some products having to go through multiple phases of iterations and all. What is maybe one engineering fail that happened in your career that you hope nobody finds out about
Oh,
until now, since you're on the podcast?
engineering fails. I mean, there's a long list actually.
Like
so
an L moment for you.
Yeah.
I think for everything that we make, there's probably a whole ton of things
Yeah.
that we didn't make that never gets to see the light of day. I will be super honest, none of the stuff that I've worked on has come out as a product yet. But it doesn't mean that the work wasn't done or that it was not good. It was, in fact, work that was done and the work that was very, very good. It just reaches this point where, number one, it's not the right time to put it into the product. It's maybe a little bit too early for its time. We can't get it in an engineering situation to manufacture. Or it's not, we didn't think that the market was there yet. Or that at the end of the day, we felt, well, this would require too many compromises that we didn't want to make. And so we said, oh, well, let's park it on the shelf. When the time comes around, we'll put it into a product again. We know how to improve it. We know what needs to be done. So we try and discard tons and tons of things just to make sure that the quality is there. So I can't tell you specifically about what those failures are.
I
You
was
can
just
wait
about
and
to
see
ask.
to see when they actually come out.
Top secret.
But we are definitely in this mode of it's fine to fail. It's completely okay. Failure teaches you something new that you didn't know before, and you learn something from it, and then you apply that to the next iteration and the next iteration, next iteration.
What about you, James?
I mean, kind of like what Shawn said. Like, I think any of the products we worked on, whether it was the hair dryers or hairstylers, like there were so many concepts we labored. I personally labored on a few of these for years, only for them to not make it out there. And then actually, if you look at a product like Supersonic R, like you'd imagine, with the original Supersonic, this is a pretty good hairdryer, right? We made it right, but we didn't settle for that. We were like, okay, can we make this better? Like, what is an even better hairdryer, right? If you look at the temperatures of Supersonic R, they are beautiful. I don't know anyone else who says this, but it's like, but yeah, it's absolutely beautiful because when you are thinking about drying hair and preventing heat damage, it's a game of managing temperature and making the temperature even. And this is just one example, right? So if you worked on like 5 products, I think you would have easily seen personally at least 50 things that didn't work. That's like 5 per 10 per product, no problem. So yeah.
And I'm assuming that when you first graduated as engineering graduates, you didn't know as much about, hair or skin care as you do now, right? So what was perhaps the most hilariously unengineering thing you had to Google at work? Like, what are bangs? Or how does hair curl?
Sometimes I just Google what is this chemical because I have no idea, and then we have to think about how that works with something else. My team, we don't work so much with the like the downstream engineering principles, so I Googled that a lot. I'm not embarrassed to admit, like thermal sensor, something something. Like it's a daily occurrence, I think, and we're very unembarrassed to admit it. It's that it's continuous learning, right? The whole process is it's one of continuous learning, and I struggle to imagine anybody who really goes into the workforce and says, I'm going to be working on exactly this topic for the next 20 years of my career. I'm sure there are people who are like this, but none of the people I've interacted with we've deviated so far from what we were originally trained to do, and in a good way. But we're not changing. The fundamental principles are the same. Science is the same. Physics is the same. That doesn't change, right? Maths is the same. How light bounces off the wall is going to be the same. It's just applied to a different set of problems.
Could you have imagined that you'd be doing what you're doing now back when you were an engineering student?
Absolutely not.
So what do you think?
No chance.
Where do you think you would be when you were a student?
I think I got into engineering because ever since I can ever remember, I was obsessed with aeroplanes. So I was that kid, that 5-year-old kid who'd stare out of the window and just be staring like, whoa, 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 look, look, look. And everyone's like, oh, why? So I think, yeah, when I was in uni, it was like that would have been an obvious choice. I think, and in many ways, I feel like it was, it also helped educate my decision to join Dyson as well. So when I interviewed for Dyson, I still remember in the UK campus, they had just moved this giant, a full-sized Harrier jump jet. It's an iconic aircraft. It's one of the first aircraft that can take off vertically, like straight up. And as an aviation enthusiast, you tend to know these facts.
Like
And
the
it was just
F-35s?
yeah. So F-35s do that as well, but like the Harrier is really old, and it's an icon, right? The engines are an icon, and so yeah, I felt like that actually nudged me. That I was like, okay, this company actually appreciates great design, great engineering. And yeah, in many ways, it's amazing. Like one of the common things we get is like this motor looks like a jet engine if you scale it up, and the principles are exactly the same. Like the physics, the design of the fan motor for our motors is the same engineering principles and tools you use to design the fan motor on aircraft. So, yeah, but I never imagined I would be working on hairdryers and vacuum cleaners for sure.
And if you take the bladeless fan and just scale it up, you get a bladeless jet engine for planes that are immune to bird strikes.
Yeah, you might want to patent that. That's a great idea. It's like,
So I mean, talking about that, if you could design one product, right, without any technological or physical limitations, what is one dream product that you would want to
A
create?
jetpack for you, maybe?
I feel like the first thing that came in my mind, I don't know what the product is, but I feel like the problems are around kind of climate change and those kind of things. I feel like if there were a product out there to solve those really pressing problems in this world, it'll be great to participate in that. I don't have an idea yet, but yeah. What about you, Shawn?
I feel like we're kind of always in this model of nothing is impossible. So it's kind of hard to think of something that, would be really impossible off the bat. I'm sure if I say something, I'll just embarrass myself because probably somewhere someone has already thought of the answer and patented it and has like 5 prototypes in their backyard ready to go or something. So this is very much how we approach things, right? Nothing really is impossible if you just put your mind to it.
I mean, as the both of you have been in this industry for quite a long time, how do you think the engineering industry has changed over the years?
I think what's really interesting is how much, I mean, you could see this happening even whilst I was going through my engineering degree, but it's so obvious now that there is really strong cross-pollination between the disciplines, stronger than any time before. So if you studied, let's say, mechanical engineering or electronics engineering in the 90s, you kind of maybe in your careers stuck into your lane, like you were in your lane, and that was okay. Like you would be very successful. But what we're seeing today with the proliferation of computers as part of the engineering process, no matter which discipline you specialize in, there is kind of an expectation that you will be asked to learn a little bit about something else and actually use and adopt it in your so it doesn't matter if your background is I don't know, like, yeah, mechanical engineering, but you need to know how to code. Like it is a thing. Like even though you don't have a computer science degree, you might need to have above average skills in coding these days. So so that is a thing that's very different and that has changed over the years.
Yeah. I think, like I mentioned just now, a lot of it is the same principles just applied to a whole different set of problems. I literally was just having this conversation yesterday with my colleague. So I trained as a chemical engineer, and in my time, chemical engineers went out and worked on oil rigs and refineries. That's what you do as chemical engineer, right? You go and like make stuff from oil. By the time I graduated, it was kind of evolving a little bit away into specialty chemicals. So how do you take these and make specialty chemicals? My specialization was in polymers, but still very much the training was fundamental. How does oil come from the ground, and how do you treat it, and how do you deal with it? And it's really funny because yesterday we were just having a conversation, and then I just found this picture while in the midst of our conversation, and it said, "Oh, this technology is equally applied to cleaning oil rigs as it is to cleaning the pores on your scalp." And I was like, "Huh, there's a pit. There's oil in it. Yeah. You got to do something about that. And there's oil in your scalp. There are like pores in it. You got to do something about that." I guess it's not really that different, but 20 years ago, I would not be thinking like, oh, let me go see how I can keep my scalp clean and use my hair device and like styling device and make sure that it's like maintaining the health of my scalp at the same time. I would not be thinking that, but actually it just kind of like was a really aha moment. And I said, what are the chances that you would actually have these two different things and it's the same technology and you would be trained to do both of these at the same time. So it was kind of a very interesting moment. I think really all the traditional principles have not changed, right? So we're just using it in many, many different ways, in many creative ways, and trying to solve problems that are very modern day problems. So having that mindset, that taking what you know, what you're familiar with, and applying it to a whole different set of circumstances, that's very much the bread and butter of what we're doing now.
I didn't know that like the skills and the knowledge in engineering is so like transferable. Like there are different fields like mech and aerospace and chemical engineering, but I didn't know like the principles and like the knowledge that you've gained is actually transferable across the fields. So I think that's pretty interesting. So maybe on that note, like do you have any final advice for aspiring engineers, both in general and in Dyson?
As cliched as it might be, as probably a young engineer or a young professional, I feel like it's really important to have goals, like as cliched as it might be. And if you can, write them down. Because I feel like in general, the world is changing very fast right around us, as a general statement, that's so true. And it's like no wind is ever going to be favorable if you don't know which direction you're going. So like just having that goal and saying, roughly speaking, this is where I want to be in my career, in my engineering career, that will go a long way. And then, it's kind of related to what I said, because things change, just embrace the change and be comfortable learning and relearning, because that's what's going to happen. No company's ever going to teach you how to make a good hairdryer. You're going to have to figure that out. And like Shawn mentioned, like usually degrees these days, they're kind of broad in their spectrum in that they give you a very strong foundation in multiple disciplines so that you can pick what you learned and apply it to the problem you're solving. And honestly, I think that's part of the journey. So I think that process of learning, relearning, whether it's tools, techniques, products, product design, I think that will go a long way.
So for me, like I said, it always comes back to you may be an engineer by training, but the trajectory that your career is going to take will take you through so many different villages and towns and paths that what I would recommend strongly is to never lose that curiosity, to learn something new, to have the humility to say, I don't know anything about that, let me go figure it out. And then find the people who do know, pick up knowledge from them to enhance yourself and enhance what you can bring to the table. I think that's the first thing that I would say. And then because we are in a consumer-facing company, we make things to sell to people. Another thing that I tell everybody that I work with is you got to know your consumer. You got to know what you're making. You got to know what you're selling. You got to know what it's supposed to do, what people want from it. You can't just be like, I'm in the back end. I'm just making the product. I just have to make sure that what I do works. I don't have to think about who's going to use it, how they're going to interact with it. I think that's not going to be the case anymore. We have to be super aware of what we're doing and where it's going to be and how it's going to be used. And that infuses your design, right, and your thinking as well. So that's extremely important.
With that, we've come to the end of today's episode. Thanks for joining us, and we'll see you in the next one.